So we're trying to do derivative of Arctan function. First part is I'm going to discuss the derivation of the formula. Then I'm going to use the formula to drive one of these, one example. Let's start with the derivation of the formula. So we're starting with y equal to arctan of x. I don't know how to do arctan of x, but I know how to take the derivative of tan of x or tan of y in this case. So what I do is I take tangent of both sides. And if I get tangent of y, and I get tan of arctan of x, then tangent of y is going to be equal to tan of y is going to be tan of arctan of x, which is x. Now, let's try to take the implicit derivative of this thing. When I'm taking the implicit derivation, then I will get derivative of the outside function, which is the tan of something, and then that would be tan of x derivative is secant of x, so secant squared of x, so I will have secant squared of y. But inside function is y. Y is a function, implicit function of x, so I will have dy dx. Then derivative of x with respect to x is going to be equal to 1. So if I want to solve for the derivative of the function, what was the function? Let's erase what I put around it. The function was arctan, y equal to arctan of x. So if I want to find dy dx, what I need to do is I have to divide both sides by secant squared of y, which is going to be 1 over secant squared of y. That is, what is secant of y? Secant of y is 1 over cosine of y, so this is going to be cosine squared of y. Now, I do not want to, in the input, I don't want it to be y. What do I want for input is x. Can I rewrite this so I can get, can I rewrite y to get x? Yes, I can replace y by what I have over there. So I will get cosine squared of arctan of x. Now the input is x, except that through the trigonometry that I know from before, I know that cosine and a trig function and an arc composed together is going to simplify somehow. So let's simplify that one. So I'm starting from here. The inside function is arctan of x. What is that? That's an angle. And so basically, it's the angle y such that the tangent of that angle y is x. What is that? Tangent is this side over this side, so x over 1. Now, I'm trying to find cosine of that angle. Tangent of angle was x over 1. What is the cosine of that angle? So the cosine of that angle, let's go over here by Pythagorean theorem. This is going to be 1 plus x squared, square root of that, right? And cosine is going to be this side over that. So cosine of y is going to be 1 over square root of 1 plus x squared. Here, cosine squared of y is what I want to try to find, and I know cosine of y is square root of 1 plus x squared. That to power 2, I get 1 over 1 plus x squared. So, what do we get? We got dy over dx is equal to 1 over 1 plus x squared. And that's the formula. And my colors are going away, so I'm going to try to use another one. Or another way of writing it is the derivative with respect to x of arctan of x is equal to 1 over 1 plus x squared. And this was the derivation. So one way of solving examples when you're trying to take the derivative of arctan function. One way is to apply tan to both sides, do implicit differentiation, and it works out well. But let's try to use the formula here. We're going to need this formula for Calc 2 a lot, so it's the best to memorize it as well. So I'm trying to take the derivative of this one. Let's call this f of x. And so derivative of f of x with respect to x is going to be, this is a composition. The outside is arctan of x. The inside is x squared plus e to the x. So I'm going to write down the derivative of outside, and then instead of x, I'm putting a big parenthesis. Derivative of outside is this. So I'm going to write 1 over 1 plus big parentheses to power 2. Then I'm going to write down the derivative of inside. What goes in here is going to be the inside that is up there. And then to finish it up, I'm going to have, and derivative of that is 2x plus derivative of e to the power x is e to the power x. I can simplify this a little bit. I use the binomial formula to expand and clean up the bottom, but this is actually quite enough for just the derivative.